Good morning, everyone. I hope you're doing well, and I hope that you're feeling good as we get started here on the final week of the semester, the final full week of the semester. Then next week we'll have reading day and get into final exams as well. So I hope you're able to access our class calendar on Google. That will show you when our final exam is, as well as your final assignment, which is the second draft of your WNC history project. And I'm working on getting the first draft of that back to you right now. And so as far as class material goes, we're only going to go through whatever lecture PowerPoints I get posted this week. So we'll see where that gets us. We may or may not get through all the material that I had on the syllabus. But if I don't have it posted by the end of this week, it won't be part of the material for the final exam. However, we're definitely going to get through forests. We were talking about grasslands last time and some ways to restore them. We're going to move into forests today. So it's unfortunate that our current conditions keep us from getting out and about. Because we have a real neat resource nearby, the Bent Creek Experimental Forest. I hope some of you have had a chance to get out there. But this is an area of the National Forest that is dedicated to conducting research to see what practices of forest restoration work well. Katie Greenberg, who's sitting down there on the left in this slide, she was actually scheduled to visit our class and talk to us about what they do at Bent Creek. But if you get a chance to get over there, they have some real neat placards and signs that talk about what they've been learning about restoration. And a big part of forest restoration in this part of the world is thinking about how our forests are going to respond to disturbance now that we no longer have a lot of the species that we used to have, right? So the American chestnut is a big example, and so they've been learning a lot about forest succession, because a lot of what the Forest Service does, of course, involves tree harvest, but they want to know what the forest is going to look like after the harvest and how long it will take it to get back to look like something that it was initially. The National Forest System, it's actually kind of interesting. We have national grasslands as well as national forests. They're scattered around the U.S. They're a little less than 10% of our land area. And so these areas have been involved in a lot of the research and a lot of the practice of forest restoration. And of course, you can see that strip of forest moving through western North Carolina from the northeast down toward the southwest a little bit. And so those are the Appalachians, right? So we're fortunate to have a lot of the Appalachians preserved within this national forest system. I say preserved, they're protected, but the management is not all about preservation. Because the mission statement of the U.S. Forest Service is to sustain the health, diversity, and productivity of the nation's forests and grasslands to meet the needs of present and future generations. And so timber harvest is also a big part of what they do, and the motto, caring for the land and serving people. All right, so let's talk a little bit about what is a forest to begin with. You can see the outline is going to be similar to our discussions of wetlands and grasslands. So essentially, forests are defined as large ecosystems dominated by trees. And so wherever that's the case, where it's more trees than grasses, it's going to be a forest. And so I'm sure you've learned in ENVR 241 and other classes that the species composition of our forests differs from place to place across the U.S. based largely on issues like rainfall, temperature, those kinds of things. And so, where we are located, we're in that light green oak hickory group, although there are patches of other kinds of forests as well. We have actually some rather extensive sections of loblolly shortleaf pine. You can see that's the type of forest that starts to take over as you head toward the coast. But we have some significant patches of those kinds of forest here in western North Carolina. And of course, again, as you get up into higher elevations, we'll see a little bit of spruce fir here and there as you get up into places like where Mount Mitchell is located, the Black Mountains, and up even further into the Grandfather Ranger District of the U.S. Forest Service. But primarily where we are, it's oak hickory forest. So forests not only differ from place to place geographically, but within a location when it comes to elevation. And so you get these very discrete zones based on a couple things, based on soil characteristics, temperature, and moisture. So if you're imagining if you were in some place where you began in a tropical ecosystem, this could be South America, Asia, Africa. As you move up higher in elevation, you go from a rainforest to more of a deciduous forest, temperate deciduous forest, finally up into some evergreen, and tundra and ice and snow. And so we have these predictable forest zones which occur both vertically, but then also latitudinally. So the transition from tropical rainforest towards a needle-leaf forest also happens as you go from the tropics toward the equator, in addition to moving up the mountaintop. And some pioneering work on community structure was done in these kinds of ecosystems. Thinking about, is the structure by competition among species, or are these patterns driven mostly by abiotic variables? And as you might have imagined, kind of the way that I talked about it, it's determined this is mostly due to abiotic factors. It's things like soil nutrients, temperature, moisture, those kinds of things. So this is our predominant forest in western North Carolina, the oak hickory forest, and really across the Appalachians and even a lot of North Carolina at lower elevations. So as I mentioned, we've talked already about how we can't go back to the past. And as I'm sure you all know, the American chestnut used to dominate these forests before the introduction of the chestnut blight. So essentially, our forests are in a state of transition, coming back from just the devastation of the American chestnut. And so we're kind of seeing, again, in some ways, succession still going on. Now, these forests naturally would experience fire somewhere on the order of every 25 to 50 years. And that would allow the reset of the successional system of these oak hickory forests to do well. And then there were also occasionally much stronger and more intense fires as well. And these are what would open up larger parts of the canopy for some earlier successional species. Things like, for instance, tulip poplar, sassafras, things like that. So again, terrestrial ecosystems, fire plays a role, and certainly the case here in our oak hickory forests. We'll talk more about them a little bit in the next lecture some more. All right, so why are forests important? This is when I would ask you all, and you would come up with all kinds of things, reasons why forests are important. But they're very large biome, right? So they're covering up to a third of the world's landmass. So this is a common habitat type. And if we think first of all about a market value, just on the U.S. Forest Service land, 2 to 3 billion board feet are harvested every year. That's somewhere on the order of $100 to $300 million. So forests are very important economically to provide us with timber. They're also home to 80% of the world's terrestrial biodiversity. So forests are more important from a habitat perspective, at least numerically, than, for instance, grasslands. Certainly the tropical rainforests, providing the lion's share of habitat for species. And then again, we'll take an ecosystem services perspective. Lots of things we could come up with here. Stabilizing the soil and preventing erosion, right? Those are the roots that will hold the soil together. They slow down the runoff and that's due to just the physical structure of the woody trunks on the land. The water can't move as fast. And so that lessens flooding, right? Because when the water moves more slowly, that means more of it is going to infiltrate down into the groundwater. And so this results in a purifying of water as well. So more of the sediment, more of the other things are able to settle out before that water hits our streams. They store carbon. You know, if you look at a tree, it's a gigantic carbon storage device, right? All of its leaves are like little machines that are taking CO2 out of the atmosphere. And then it's turned into these structural carbohydrates, right? Things like lignin and cellulose that make trees hold together really well. If you've ever been unfortunate to be in a car that's hit a tree, you realize that the car gives a lot more than the tree does, right? So the incredibly strong carbohydrates made out of this carbon. And as you all know, of course, trees release oxygen. And that leads to a moderation of climate for a couple of reasons. It absorbs the rays of the sun by having our land covered with trees, so we don't heat the surface of the earth as much. And also, trees will release moisture and some other compounds as well from their leaves, and this all sort of creates an insulative layer around the earth. So when we have trees, it's going to moderate the climate. So forested ecosystems have much less temperature variation over a daily 24-hour cycle than do urban ecosystems. The Amazon rainforest produces about 20% of the Earth's oxygen. Now, I have to say the majority of that oxygen is cycled locally. You know, it's not that we here in the Southern Appalachians are relying on the Amazon for oxygen, but nonetheless, that's a pretty high rate of production. So we have to talk about carbon, right, in the context of climate change. So again, trees, through the process of taking CO2 out of the atmosphere with their leaves and turning them into these structural carbohydrates in the trunk, are a carbon sink. And to give you an idea of how much is stored in trees, about 7 times the amount of CO2 emitted by humans each year is held in forests. But of course, when we have deforestation and timber harvest, as we've shown here on the bottom, the trees stop being able to do that. And it's exacerbated if that wood is burned, right, which then puts that CO2 right back up into the atmosphere. But if that timber was to be turned into lumber, that carbon would essentially still be sequestered in the boards and the timbers of homes. Although we also have to remember that simply harvesting this much timber is going to take a lot of fossil fuels to run the equipment and the machinery to get that done. U.S. Forest Service study found that about a third of carbon emissions were absorbed by forests. So they're playing a pretty big role here in helping moderate the climate. So how have forests been degraded? A bunch of different things going on. So they can be converted to agriculture, forest fires, it can be logging, and this logging is a problem primarily if it's illegal and unsustainable, because there's a certain rate, of course, that we can cut down trees that matches the rate of tree growth in a patch of forest. So any kind of unsustainable logging is going to be problematic, and illegal logging is unregulated, so that's going to be a big problem. Harvesting for fuel wood, especially in the global south, where people don't have access to other ways of producing energy. I'll talk a little more about that in a second, but that's been a big problem. And then non-native species have decimated forests as well. So the chestnut blight was one of our first examples of that in our neck of the woods. Nowadays, it's the hemlock woolly adelgid, right, which has come over from Asia and is hitting our hemlocks pretty hard. But there are lots of other either pests or diseases that have come over, and so these are all factors that threaten forests. Nowadays, the conversion to agriculture is somewhat lessened. we lose more forest nowadays to forest fires than we do to agricultural conversion. So deforestation has been dropping globally. The UNFAO estimates that deforestation rates have dropped by about 50% in the past 25 years. But they have not dropped to zero, such that it's estimated that within the next 100 years or so, we could lose our tropical rainforests. Here's a graphic showing that. This is the annual net loss of forested area in percentage globally, and you can see that the rate in the first decade of the 21st century is about a third that of the rate toward the end of the 20th century. So we're definitely getting better at deforestation, but still have work to do. So part of the story here, so I should mention, we gave a presentation at the U.S. Embassy in Kathmandu, and there's a woman there who was really thrilled about these results because the U.S. Embassy has been working really hard to try to help promote programs that reduce deforestation. So this is a really great data point for them. And part of the technology that has been adopted here is use of locally produced natural gas. So a lot of folks in rural villages, instead of having to bring in wood to start their fires for cooking and such, were helped to construct biogas digesters. And they're these big cement tanks with kind of a cement dome on the top. And most of these families have cattle or maybe a water buffalo. And so what they would do is they would take the manure from the cattle and water buffalo and put it into these biogas digesters. And then as it decomposes, this contraption actually collects the gas, and they can use that to fuel like a gas stove. So there's been a great reduction of the amount of deforestation that needs to happen in Nepal. And again, as we saw, that's been a trend that's been going on around the world, including Western North Carolina, as we'll see in just a moment. Let's take a look at a forest in a couple other parts of the world. So in the former Soviet Union, there was a lot of unsustainable resource use that went on under the former Soviet Union. And so the boreal forests in the upper latitudes in Europe are growing back, and there's a net absorber of CO2 from the atmosphere. Now, on the other hand, the boreal forests in Canada, believe it or not, are currently net carbon emitters because they had been, up until just recently, experiencing pretty severe drought and also damage due to beetles, such as the mountain pine beetle here. And so when those beetles kill trees and that tree decomposes, you've turned a carbon sequestration device into essentially a source of carbon for the atmosphere as it decomposes. So it just shows the potential negative impacts of these pests, turning a forest into a net carbon emitter. It's hard to believe. So what we're seeing in general, however, though, is that in North America and Europe, forests are regrowing across areas that were once cleared for agriculture. And so these areas are now absorbing about a third of all the carbon absorbed by forests globally. So reforestation is actually becoming a really strong dynamic. Our agriculture is getting more intensive, which has lots of issues related to it. But one of the good parts of it is that we need less land. And so we're able to let more land relax. So essentially to go back to forests. This is what that process looks like in Western North Carolina. This is a study done back in 1998 where they looked at land use and land cover characteristics of 4 different areas. So the Keene Creek watershed, that's the watershed out in Fairview that cuts across down on into Fletcher, across I-25 and enters the French Broad River. Not too far from Hendersonville. They looked at Grayson County, Madison County, both some rural areas, and then also the Little Tennessee River basin. And they looked at the percent forest and the percent agriculture. And so in Cane Creek, for instance, in 1950, it was about 60% forest, 30% ag. Come 1990, it had increased by about 5%, about 5.5% in forest, and it lost about 8% from ag. There's also an increase in urban development there. But then in those other areas, you can see about a 24% increase in forested landscape in Grayson County, 8% in the Little Tennessee, and in Madison County was the most dramatic. From 1950 to 1990, there was a 20% increase in the amount of forested landscape. And you can see that was due almost entirely to a reduction in the amount of land used for agriculture. So across western North Carolina, and indeed across a lot of the global north, we're seeing an increase in forested lands as that agricultural land essentially goes back to forested landscapes. And a part of that dynamic is that some of those agricultural lands are being turned into low density development, so where you have a relatively small number of homes per land area. And so in those types of developments, there's usually a large amount of trees as part of that. So it's kind of a snapshot at what forests are, how they've been degraded, and just a little bit about current trends in the global north and western North Carolina and globally as far as what's going on with forests. And we'll continue this discussion in our next lecture.